This lesson's objection is to write a piecewise function from a graph. To make a piecewise function from a graph, we must be able to identify the equations of both lines. So what I've done is highlighted by using different colors each different piece of the function. Before we go too far in this, I'd like to review how to make an equation of a line from 2 points. To make an equation of a line from two points, we will use the point slope technique. Given 2 points, we will calculate the slope first, given as y2 minus y1 over x2 minus x1. Now we have a point and the slope. From here we can set up an equation in the point slope form. The point slope form of the equation looks like this. Y equals m times x minus x1 plus y1. You may have learned it possibly like this. Y minus y1 equals m times x minus x1. Perfectly fine to use that technique. However, we would like to solve our equations for y. To do this, you would have to add y1 to both sides. When you add y1 to both sides, you come up with the equation I wrote up here. To save time, I'm just going to start off with my equation in this format. So back to our piecewise function. We have 2 separate lines or pieces of lines making up one function. So it's very important that this is not 2 equations of 2 separate lines, but one function of x that is comprised of 2 pieces of lines. So what I'm going to first do is describe the first line by finding 2 points on that line. Whenever you're using a graph, all of your points are estimates. So what we're trying to find is any points that appear to be integers, which means cross right at a nice integer point. So here's one point on my red line, -2, 0, and another point is 1, 2. From these 2 points, I can calculate the slope of this red line. The slope will be 2 minus 0 over 1 minus a -2, giving me 2 over 3. So that's the slope of my first line. Now I'm going to write that line in point slope form. The slope is 2/3. I can use either point I want to. I'm going to go ahead and use this point because the values are positive. So I subtract x1 and I add y1. This is the equation in point slope. If you want to, you can simplify this equation and put it into slope intercept. Now I'll go ahead and do that real quick. The only problem with solving this for slope intercept is now your equation is written with fractions. I'm perfectly happy with fractions. However, if you want to avoid using fractions, then leave the equation in the original integer format, and the only fraction we have is the slope. So that is the equation for the line that represents the first piece of our function. Now we're going to look at the second piece. What's important to notice is this point is also on the second piece. However, I'm going to need another point. Any point what looks like I have integers will be a good point. So this point is the point 3, 4. So now I'm going to calculate the slope of the blue part of the line. So I'm going to have y2 minus y1 over x2 minus x1. giving me 2 over 2, or a slope of 1. When I put this into point slope, point of 1, our slope of 1 minus 1 plus 2. And again, I'm using the first point. I have integers, which is helpful, and I can simplify this one, giving me my equation in slope-intercept. Now, again, you can either use the point slope of the form of the line or the slope-intercept. In this case, I'll go ahead and use the slope-intercept because my answer is in integers. Now, what's important to remember about piecewise functions is I have one and only one function. So I only have one set of y values. That's it, one set of y values, and we can use function notation. And that one set of y values is going to come from a set of possible equations. So this symbol here represents that I have more than one equation to represent my function. So the first choice is going to be the 2/3 x minus 1 plus 2. And I can make that choice when x is less than 1. Less than, we'll put the equals here. Now what's important about this statement right here is not only have I told you what the equation of this piece of the line is, but I've told you when you can use this piece. It can only be used for x values less than or equal to 1. The next piece is x plus 1, and we can only use this piece when x is greater than 1. Now, what you'll notice is this has an equal sign as part of my inequality, and this does not. That is because it's a function, which means a function may only have one output assigned for any given input. Since my two pieces intersect here, I can only use the x for one or the other. Technically speaking, it would not matter if I used it for the first one or the second one. I'm going to now give you an example where it would matter. In my second example, again I have one single function of x, and what you need to notice is my two pieces are not connected. This really does not affect how we address the problem at all. First thing I'm going to do is describe one of my pieces. It doesn't really matter which piece you describe first. I'm going to start off just because I like to start from left to right. As I move from left to right, you'll notice my y value doesn't change. This is a horizontal line, and this horizontal line can be described as y equals -3. Because this line was a horizontal line, this is all we need to describe the blue piece of our function. Now we're going to move to the red piece. The red piece is not a horizontal line, so I'm going to need to use point slope. I'm going to start off with a point, 2, 0. That's this one right here. And I'm going to find another point that appears to be an integer set, such as the point 4, 2. I got 2 points now on this piece. And I'm going to set it up by calculating the slope first. y2 minus y1 over x2 minus x1 gives me 2 over 2, or a slope of 1. So, to put it in point slope, y equals the slope times x minus one of those x values. I'm going to choose the first point as 2, 0, minus the plus the y value, which is 0. And we'll go ahead and simplify this to y equals x minus 2. So once again, I'm left with two equations of two different lines, but what I have to recall is I only have one function. So there's only going to be one y value ever coming out. Whenever you write a piecewise function, this is really important that you only use the y symbol one time. So my y value is a function of x, and it's going to come from a set of choices. So this is where this notation comes from. This is telling anyone who would use this that I have a set of possibilities and we can only choose one of those possibilities. I'm going to start with the possibility that y equals -3. It's important. I have my y value, the left side of the equation represented over here, and the right side of this equation all written in there. Do not write a y equals -3 inside the set notation. However, I must tell the user when you can use this piece. This piece can only be used when x is, let's take a look at this point here. This is the point 2, -3. However, it's an open point, which means you cannot use that point, but you can use anything as close as possible to 2. So I simply say x must be less than 2. I cannot include an equal sign on this part of my formula. So, next equation, I have the y part, the left, already written out. Now I'm going to put in the right side of the equation, x minus 2. So notice I have y or f of x equals x minus 2. But the set notation told me I am limited when I can use this. So when can we use this? Well, we start off by using the x values at 2 or larger. So in this case, you are allowed to use the 2. If you use the 2 symbol on both of them as being equal, it's wrong, because x cannot be 2 on this part of the graph.